This is actually one of my favorite things to talk about, because establishment science, they want you to believe that somehow outer space came from rocks that were traveling billions of miles and then seeded life onto the Earth. That's unnecessary, people. This is the Miller-Urey Experiment. Okay? What this is an experiment that was designed by Miller and Urey to show how organic molecules could form given the right conditions. Okay, so here we are. This is a chamber. Okay, this is an electrode. This is where the electric current goes through. This is where the spark is. This chamber holds gases of a primitive atmosphere. NH3 is ammonia, H2O is water, CH4 is methane, and H2 is hydrogen gas. That's what they used inside this chamber. This is a condenser. The condenser has cold water in it, and this gas is really hot. The condenser cools the water down after, it's been sparked and stuff, and all of the material has been mixed together. And it is trapped inside this trap right here, and here you have a sampling probe to take a sample of it. And this cooled water contains organic compounds, the beginnings of amino acids. Actually, I think it formed a lot of different kinds of amino acids. On this side, you have your water ocean, the heat source, which heats the water up, and then you spark it with all this extra gas in it, and this is the vacuum pump. Anyways, this little tube right here is the whole thing, all connected. And basically, it shows that if you take molecules and you put a spark through them, you electrify them, and you heat them, you will have organic molecules formed. Notice how you'll have organic molecules formed absent any decomposing organic material. That kind of puts a wrench in the works to the belief that natural gas and oil were formed from decomposing organic material. No, they weren't. They can be formed inorganically, just with electrical current and heat. Now, to address the idea that outer space rocks need to seed life on Earth, we can go ahead and falsify that. Or, I wouldn't say falsify, we could just render it unnecessary or ad hoc. Because during stellar evolution, the molecules that form as the elements recombine and cool are ammonia, water, methane, hydrogen gas, among many, 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 many other different types of molecules. But these are the four main ones that I'm going to be talking about right now. And as the star cools, obviously the people who have read stellar metamorphosis understands that it shrinks and it loses a lot of mass to solar radiation, solar flaring, coronal mass ejections, and the like, to eventually resemble an object that looks like Jupiter, or Saturn, or Neptune, or Uranus. And guess what molecules are in very, very, very large abundance on these objects? You named it, or you said it: ammonia, water, methane, hydrogen gas, in very large quantities. And guess what else is on those objects? A whole bunch of electrically charged material, ionized materials floating around in there. When you have huge clouds moving at hundreds of miles an hour, you better damn guarantee that there's going to be charge buildup, similar to the capacitor method for lightning on the Earth. All you have to have is a cloud moving over an area, and it will grab charge, and then it will equalize. Boom, you have huge electrical storms that occur inside of these objects, providing the electrode of the experiment. You have the elements, you have the electrodes, you have your water, there's lots of water on there, and you have the heat source. Because those objects in the interiors are still really, really hot from earlier stages of evolution. They still haven't cooled to the point to where they can host life on their rocky surfaces, which are forming in the central regions of those stars. They still have a long, long way to go. But in addition to this, what we can predict is that after these amino acids form in the trap, I would also actually look at this as sort of a gravitational system as well. I mean, you would have electrical activity in the higher regions, higher atmosphere of the star, and then you have your molecules, okay, that are electrically interacting with each other. And then you have your water, which is still superheated right below that. And eventually, as these molecules form amino acids, they fall below to inside of where the superheated water is, which then starts doing even stranger things inside of it. The amino acids can clump together. The amino acids can act like, remember the soap molecule that I showed you earlier, where you had the hydrophilic and hydrophobic soap sorting out the organic material. So the organic material was in the center and the water was on the outside. And you have materials like soap-like materials taking that then formed amino acids and then doing something else with it, forming, well, very early stages of life, such as micro or organelles and things like that. But that's for another talk. I'm sure you guys can get this. The formation of life is a direct result of stellar evolution itself. As the star cools and dies, it just combines its elements with basic chemistry and forms amino acids, and then other steps take over after that. It's pretty easy to understand.